Note page 221, looking at the example questions at the bottom, kinetics and equilibrium. So we are given a system at equilibrium, which we have an ionic compound, AgCl. It is dumped into water, and so it is pulled apart into the individual ions. When HCl is added to this system, notice that the HCl, if I write it down underneath, dumped into water, it also supplies ions into water, and like our original salt, it also dumps extra chlorides in. So this is what is added to the system. Okay, so based on where our stress is an addition of chloride ions, the chloride ions are on the product side, so it wants to cause the system to shift back towards the reactants. So that means our system is going to shift to the left. So I'm going to get rid of response 1 and 2, wrong direction. And because it's shifting back to the left, look at what it's going to remake. It's going to remake solid AgCl particles. So what happens to freely moving Ag+? So this is the stress. What we shift away from decreases, and what we shift towards, the amount available, increases. So since we're shifting away from the silver ions, its concentration must decrease, making response 4 an incorrect. So best choice is response 3. Okay, next question. Okay, we have a closed system at equilibrium. It contains hydrogen and iodine and heat on the reactant side, and hydrogen iodide on the product side. What will result due to an increase in the temperature? So this is the stress. Now notice there are no degrees Celsius or kelvins within the reaction of the system, so you have to think about, well, when you change temperature, you are changing the system's heat. So this is actually the stress. And if we increase the temperature, that would be the same thing as we add heat to the system. And since heat is a reactant, we want to shift away from the reactant side. So that means our system is shifting to the right, which makes response 1 and response 2 incorrect, wrong direction of shift. And now think about it. When the system shifts from reactants to products, right, what we shift away is used, so their amount available decreases, and what we shift towards, more is made, so it increases. So it talks about H2, which is a reactant, and its amount is decreasing because it's being used. So response 3 should be eliminated. Best answer is 4. Last practice problem on this question. So once again, we have a system at equilibrium. Here is our system, and it's asking you the amount of SO3 will increase if the concentration of. So this is a result of the shift. So result of the shift. So because of the shifting, right, we want to see this increase. So that means we want to shift to the right. What kind of stress? So in this question, we have to pick out the best stress that will force the system to make more SO3. Well, if we increase the amount of NO, which is a product, that would make the system shift left. We want the system to shift right. If we add SO2 to the system, it's a reactant, so we will shift away from the addition. That will make it go right. NO2 is a reactant. If we remove some NO2, then this the system will shift towards it, so that makes it shift to the left. And SO2, if we decrease its amount or remove it as a stress, the system will shift towards it, making it shift to the left. So the best answer here would be response 2. If we add more SO2 to the system, there's too much, the system shifts away and wants to make more of what's on the other side of the arrow.